everybody, my name is Bruce and welcome to the last in our series of lessons on chemical solutions. Today we will consolidate everything we have learned so far and use our skills to identify 3 unknown salts. We have placed them in 3 test tubes labelled A, B and C respectively. Notice that all 3 of the salts are white. We have also been given a range of substances and other tools to assist us in our investigation to determine the cations and anions of these salts. We will use silver nitrate, barium chloride, nitric acid and calcium hydroxide to identify these salts. We have access to distilled water, a Bunsen burner and a thin piece of wire for flame tests. We have also been given some clues about these 3 salts to help us identify them. Because there are thousands of salts, these clues will be extremely helpful to us, so I suggest that you write them down. The first clue is that one of these salts is an ammonium salt and the other 2 are sodium salts. The second clue is that each of the salts contains a different anion, a chloride, a carbonate and a sulphate. Let's begin to solve the mystery of the unidentified floating objects. As always, the first priority is to draw up a table so that we can note down all our observations. I have drawn up this table so that I can keep track of all the results and observations throughout our investigation. We're going to start this investigation by testing for cations. We must distinguish between the sodium cations and the ammonium cation. Can you recall the procedures we used to identify cations? Well, we'll begin with the flame test. We have to dip a piece of wire into each of our unknown salts. Ensure that the wire has a few grains of the salt on it. Hold the wire with the salt on it over a Bunsen flame and carefully observe the color of the flame. Remember to dip the wire in the hydrochloric acid and hold it over the flame after testing each substance to ensure that it is clean. Now let's tabulate our observations and deductions. Salt A gave us a yellow-orange flame. It may be sodium. We need to make sure it is not ammonium before we can be absolutely sure. The test on salt B also shows a yellow-orange flame. Like salt A, it may be sodium, but we would have to test for ammonium before we can be absolutely sure. The test result for salt C is a dull yellow flame, not nearly as bright as for A and B. This could indicate that salt C is an ammonium salt. It's important to note that a negative result can be just as important as a positive one. Now we already know that we have 2 sodium salts and the other one must be an ammonium salt. So we need to confirm our initial test by testing for the ammonium ion. Can you remember how this was done? Here are our tests for the ammonium ion. First of all, ammonia has a distinctive sharp smell. Now when calcium hydroxide powder is added to any ammonium salt and heated, large quantities of ammonia gas will be given off. We can test for ammonia gas by using moist red litmus, where the litmus paper will turn blue, or using hydrogen chloride gas, where thick white fumes will form when hydrogen chloride gas is brought near ammonia gas. Now let's use these methods to test each of our unknown samples. We set up 3 clean empty test tubes and label them A, B and C. Add a teaspoon of each salt, A, B and C, to the test tubes A, B and C. Now add a teaspoon of calcium hydroxide to each of the test tubes and stir the mixture. Heat each of these mixtures over a Bunsen burner. Place moist red litmus paper over the mouth of each test tube. Make sure that you tabulate your observations. In test tube A, the litmus stays red, so it must be definitely the sodium cation. In test tube B, the litmus remains red as well, definitely the sodium cation. While in test tube C, the litmus turns blue, which confirms the presence of the ammonium cation. We can confidently say that A and B are our sodium salts and C is our ammonium salt. We have successfully identified the cations in our unidentified floating objects. Now we need to identify the anions. From our clue, we need to find out which one is our chloride, which one is our sulfate, and which one is our carbonate. Let's begin. First, we dissolve each salt in distilled water to form a solution. We will use small amounts of these solutions to test for the different anions. For each test, we must use clean, dry test tubes and label them A, B, and C. You will notice that all the solutions are colorless. If the test tubes are not labeled, we could easily become confused about which solution we are testing. We are going to test for the chloride first. Do you remember which substances we were given to aid our investigation? Which substance is used to test for a chloride ion? From our previous lessons, you will remember that silver nitrate is used to test for the presence of the chloride ion. If the chloride ion is present, a white precipitate of silver chloride is formed as soon as the silver nitrate is added to the solution. We will also add nitric acid to see if the precipitate remains. Now let's have a look at the test. Add a few drops of silver nitrate solution to each of the solutions in test tubes A, B, and C. Watch carefully and record your observations. Here I have recorded my results. As you can see, a white precipitate formed in test tubes A and C. No precipitate formed in test tube B. Now we must carry out the second part of the silver nitrate test. Nitric acid needs to be added to the precipitates that are formed. Watch carefully as we add the acid to the precipitate formed in A and C. Remember, only one of the salts is a chloride. The other precipitate must be a carbonate. Now let's look at our completed observations to see if we can make any conclusions. These results show that C must contain a chloride anion. We also know that C tested positively for the ammonium cations, and we can therefore conclude that in test tube C, the salt is ammonium chloride. Well, that's one substance down and two to go. We have a strong suspicion that test tube A is going to contain a carbonate because the white precipitate dissolved on the addition of nitric acid, which means that test tube B could contain the sulfate. Let's do the test to identify the carbonate and sulfate anions. We will do this by adding barium chloride to fresh samples of our solutions. Have a look at what happens when we add a few drops of barium chloride to each test tube. Both test tubes have a milky white precipitate. This means that both of them contain either a sulfate or a carbonate. To distinguish between the carbonate and the sulfate ion, we need to add a little nitric acid to each of the test tubes. We will add a small amount of nitric acid to each test tube. Observe carefully. The precipitate in test tube A dissolves in the acid. Bubbles of gas are given off. The precipitate in test tube B is insoluble in acid. These results show that test tube A contained the carbonate ion, while test tube B contained the sulfate ion. Let's note our final conclusions. Test tube A contains sodium carbonate, while test tube B contains sodium sulfate. The mystery of the unidentified floating objects is solved. However, I would like to perform one more test to confirm that test tube A did indeed contain sodium carbonate. What I would like to show you is what happens when I add acid and the gas that is formed is bubbled through lime water. What we need to do is add the acid to sample A and then quickly put the stopper in place. The gas releases bubbles through the clear lime water. Do you notice that the lime water turns milky? With this final observation, we can confirm that the salt in test tube A was indeed a carbonate. To clarify the anion identification tests, let's have a closer look at the chemistry of some of these tests. For the sulphate test, the ions are sodium cations, sulphate anions, barium cations, and chloride anions. Can you see that barium ions will attract sulphate ions to form a white precipitate? So we have an ion exchange reaction. Sodium sulphate plus barium chloride gives us barium sulphate plus sodium chloride. These tests for the unknown ions are really quite amazing. And this type of chemistry we call analytical chemistry. Analytical chemistry has great importance in industry, medicine, and in forensic science. The procedures we have carried out show the basic principles behind the more sophisticated techniques used in a chemical laboratory. I hope you've been challenged to think and to find answers to problems through careful thought and controlled experiments. Whenever you're faced with a problem, never give up searching until you find the ultimate chemical solution. Thank you and goodbye.